We'll walk through the PaaS setup first. What you see here is the PCF foundation with pivotal application service or PaaS deployment. From the application routing point of view, there are two layers here within the PaaS foundation. Compute layer, which is bunch of Diego cells, and network layer, which is a bunch of Go routers. Each Diego cell and a Go router is a separate VM managed by Bosch. The platform network is managed by Bosch. So the IP address you see here on the Diego cell, whether it is 10.0.4.8 or 10.0.4.9 on Diego cell, that is all managed by Bosch. Now, from the TLS termination point of view, there are two options. You can either terminate the TLS at load balancer, the infrastructure load balancer, or at the Go router. Acme selects option to terminate the TLS at the Go router. Now, the Go router is a component of the platform. The certificates that are necessary to terminate the TLS are managed by the platform. Acme already sees this as a major plus point as it reduces the need to file tickets to manage the certificates and retrieve the certificates. Now let us see what happens when trading application is deployed with trading.acme.com as a route. This route is a publicly accessible route. First, Diego places an application instance in a separate container. So each application instance is placed in a separate container on different Diego cells. Now, Diego does it in an optimal way to give maximum high availability across different availability zones. Now, how that placement is done is outside the scope of this session. The bottom line is the AI count or the number of containers is based on the desired scale in the application manifest. The container is created with the application process running in it and listening on port 8080 within the container network namespace. The container gets its own IP on the overlay network, which is managed by the CNI plugin, such as Silk in this particular case. Container gets its own Envoy sidecar proxy. The application developer doesn't write anything to get that, the platform does it for you. So every container has two processes. One is the application process and other one is the Envoy sidecar process. These are two main application processes within the container. There are also other processes to monitor the health of the container. That's a different topic. So container gets its own Envoy sidecar proxy along with the application process. The Envoy proxy uses a X509 identity certificate that is specifically created for this particular instance of the AI or the container. This certificate is used by Envoy to terminate the TLS. The Envoy listens on port 61001. That's the internal TLS proxy port. So this port is in the network namespace of the container. The beauty here is that the Diego rotates the client, the X509 identity certificate every 24 hours. And all of that happens without any application downtime. This entire process, right from the container creation, placing the Envoy proxy in there, scaling the containers to desired scale, managing the TLS termination, creating the identity certificate, all of that is fully automated by the platform. So the developer or the operator doesn't write a single line of code to make it happen. On top of that, this happens irrespective of the language in which the application is written. Whether the application is the Java, .NET, Node, it doesn't really matter. The platform does it for you. So right there, Acme CIO realizes several additional tickets have disappeared now. So any traffic on port in this particular case, as you can see. All right. So what we have seen so far is that the container has been created, the Envoy proxy has been set and everything, but we want to make sure that the traffic actually is received on the Diego cell that is forwarded to this particular container. For that purpose, the Diego cell allocates a port on the VM, and that port is mapped to the container port. So this is done to make sure that the external traffic reaches the container. And again, platform does that for you. So for every container with external route, Diego does this for you. It opens a separate port on the VM. In this particular case, as you can see, the Diego cell has allocated port 61006 on the VM, and a VTAP pipe is created between the cell or the VM network namespace and that of the container. So any traffic on 61000, 61006 will flow to the port 61001 of this particular container. Now all of this is managed by routing tables. The entries into those routing tables are managed by CNI plugin. It takes care of all of that. Now CNI plugin comes as part of the platform. You don't have to plug in extra CNI plugin just to make it work. Now, once the CNI plugin does the entries into the routing table, the rest of it is managed by the Linux kernel. So once this container and network setup is done on the VM across multiple Diego cells based on desired scale, the route emitter on every Diego cell publishes the combination of cell IP and cell port to the Go router, right? So the Go router maintains the map of the application routes to these combinations, IP cell port combinations. And Diego does that for every application that gets deployed with external route. So for example, in this particular case, as you can see, the Diego has the map for 2 application instances for trading.acme.com mapped to the Diego cell and IP, Diego cell IP and ports on these 2 VMs. Now, all it knows from the routing point of view, all the Go router knows from the routing point of view is the application route and the cell IP and port combination. This entire process, even the emitting the routes, maintaining the routes, maintaining the route to IP cell mapping, all of that is managed by the platform. Now, that is an additional benefit that the CIO realizes, where the tickets are reduced even further. Now let's see that another application is pushed onto the platform with route billing.acme.com. Let's see what happens then. As you can see, the billing application route also gets its own dedicated port on Diego cell for every application container that the billing application requires. As you can see, the green ports are given to the billing application. Orange ports are kind of highlight the ports allocated for the trading application. And as expected, the Go router also gets the map or maintains the map for billing application now, mapping it to the cell IP and ports for that particular containers. Now let us trace the request from end user to the actual application container.